Here we want to look at an example of a motion of a projectile. So we are given a projectile that is given an initial velocity of 10 meters per second at an angle of 30 degrees with respect to horizontal at A. And it's going to reach point B. Point A, as you could see, is 8 meters above B. So we could pick actually the references as given. So our reference is the XY given. Or you can move the reference actually to point A. So you can draw an x-axis at point A. But in any case, let's say the objective is to find, we want to find the following. We want to find the time it takes for the projectile to go from A to B, the horizontal distance traveled, x, by x we mean this distance, x, and then also with what velocity it will hit the floor or the x-axis. So velocity at B at that instant. So let's go ahead, let me just erase these. Now one of the first things we want to do is to take that initial velocity of 10 meters per second and resolve it into two components. In other words, we have a horizontal component and a vertical component, V0x and V0y. So V0x is going to be 10 meters per second times cosine 30. So that's going to be 8.66 meters per second. And V0y, the y component of the initial velocity, is 10 sine 30, which is going to be 5 meters per second. So you need to do that all the time. So now, based on the equations that we have for projectile, to find the time, since we know the initial height, so if we use this equation, y equal y0 plus v0 yt minus 1/2 gt squared. Remember, g is just 9.81. The negative is already considered in the equation. So the initial height is 8. So this is 8. The final height when it reaches B is 0. V0y is the 5 times t, and then minus 1/2 9.81 t squared. So now you have this quadratic equation, which is, if you clean it up, is 4.905 t squared minus 5t minus 8 equals 0. And you have to go ahead and solve this quadratic equation using quadratic formula. So let me give you the answer. T comes out to be, actually we're going to get two answers for t, but one is going to be negative. So we can't accept that. So t comes out to be about 1.787 seconds. So now the question is, once you find the time, so we took care of the first objective. Now we need to find this horizontal distance traveled by the projectile. So let me go back to the next page. So now we have a formula for horizontal position that's equal x0 plus v0 xt. Of course, x0 is 0 because we are right at the reference. So v0x, recall it was 8.66, and the time we just calculated. So the distance horizontally, or the distance from the reference at B, comes out to be about 15.5 meters, roughly. So we also got the distance traveled horizontally. Now, the last thing we want to determine is the velocity right at B, just before this guy is about to hit the axis X. Okay, so we know in order to find velocity at any point we need the x component of the velocity. Now x component of velocity is always constant because we're neglecting the air resistance. So the only acceleration we have is gravity. So that's actually 8.66. And the y component of velocity is determined based on this formula, v0y minus gt. So if you put the v0y, which is 5, minus g 9.81 times the time, 1.787, Vy comes out to be equal to about minus 12.53. So it should be negative because, as you could see, what we had is actually we have an x component of 8.66. So this is the 8.66, and you have a y component of about 12.53, right? And the velocity just at b is going to be the resultant of the two. So square root of 8.66 squared and negative 12.53 squared. This comes out to be roughly about 15.23 meters per second. So that would be velocity just before the projectile is about to hit point